our first approach with AI and machine learning started in the late 2018 with a specific use case whose detail I will share later. At the time, we didn't even realize that we were starting a journey about AI and machine learning, because at the times, technology wasn't so known as today. Driven by the enthusiastic results and the many new ideas that we generated during this first experience, we later evolved it into a full AI ML transformation program, expanding across the entire product process chain of our plant, local plant. Our current goal is to set new operational and quality standards for our products by applying AI ML techniques to the key processes that govern the production, both internally but also externally to our critical suppliers. So we are applying also on suppliers. We envision a factory where all manufacturing processes, internal and external, are connected and guided by AI and ML systems. These systems continuously communicate, analyze data, compare them with historical performance, and will generate intelligent insight and prescriptions to optimize our key performance indicators such as reliability, acoustic performance, which is very important for us, and also lead time. So this is our vision for the next few years. The direction and the destination was clear from the start, but the path to get there was entirely new for us. And I would say in some way it still is. It starts with data. High quality and accessible data is essential for AI to generate meaningful insight and predictions. AI differs from standard automation because traditional automation improves how process runs. AI goes further by analyzing data, making decisions, and adapting over time. Successful AI adoption requires strategy, solid foundations, and continuous learning. On a first approach, better prioritize value-driven adoption. So start with a high-impact use case, learn from them, and then expand across the production network. Meanwhile, you can build a team. Solution must be scalable and aligned with long-term business objectives. So organizational readiness is a key factor also. AI adoption succeeds only when process roles and decision-making structures are prepared. Cross-disciplinary collaboration is also essential. And last point, empower people and foster continuous learning. Free operators and engineers to focus on, I would say, strategic and initiative tasks. Teams must be trained also to monitor AI ML systems, to validate outcomes, to continuously refine models to maximize value. And I would say this is all of my presentation. So thank you for listening and enjoy the rest of the conference.
First of all, my advice would be to start small and simple. Sometimes when you are very ambitious, right, to start your RPA or AI journey, just calm, take it simple, and try to start with something, a process very, very small, okay? And try it, and then with time you can put or automate process, bigger processes, and so on, right? So that would be my advice. Second, do not fall into trends. As I mentioned, the market offers a huge variety of technologies. Other companies are very successful, so you take a look into the news. Oh, I want to be like this organization, but please just do not lose focus and be strategic with your organization. Third, my third advice would be what works for others may not work for you. And this is regarding the strategy that you follow for the journey and also the technology that you are choosing. And one tip from my side, from a technical perspective, is go to congresses, go to this kind of events where organizations are showing the technologies that they are offering. Then you will be able to learn what's best for your organization. And last but not least, Yeah, communication and people are key, as I was commenting during the whole session. And finally, the robots monitoring is crucial. Okay, so pay attention after they go live. Let's not leave the bot die with time.
Create some real value. The point that I'm trying to drive here, most companies are focusing on tools. I'm sure you and all your companies have access to tools. So it's kind of the tool mindset that actually lead a lot for us to focus on deploying AI. But the companies who are looking at mindset, embedding it's in people and trying to get people to understand it, actually more likely to innovate and actually outgrow many times than the peers who actually looking at and just using AI as a tool. So there's a kind of a small framework to bring all that to kind of life. So the first thing is that we look at, how can we augment our thinking? The second one is possibilities, that it can create endless possibilities. The third one is the collaboration. So looking at augmentation, using AI as a thinking partner. When you're working on something, you probably get stuck. You probably find it challenging. Can you use AI as a partner than a tool? I have myself in the past, right? If I want to write something, if you want to polish something out and check my grammar or etc., I would actually use as a tool. But I have shifted my thinking. I think, oh, what if I collaborate? What I start thinking with AI, what possibilities actually it could bring it in? The possibilities are endless. It's beyond limitations. We have capacity to do a lot of things, but also we have a lot of ego when it comes to possibilities, because you think you are the creator, you wanted to do the things yourself. But if you really open up and ask AI, right, how can I solve this problem? You can bring in different perspectives, different possibilities. The possibilities are endless. The real spark is really happen when you start collaborating. What I've found myself, it was kind of, I'm sure you all have been there as well in the past. We have kind of, it's like the AI or the Gen AI is a secret tool that you use to, kind of outsmart others. But what I found that when I start sharing with others, what I learn, they actually have better ideas than I have. Do you know that you can do this too, right? One good example, I had no idea of Notebook LM, if you have used it, right? It's a fantastic tool. Somebody said, oh, have you used this one? I was like, no, I have looked at it, and you can create podcasts, you can learn new things, you can have mind maps. I would really recommend go and have a look. It's just a great a tool for learning or aggregating information or consuming information. If you have 45-page document, which you're not fancy reading, you can just do a podcast of 10 minutes and you can watch it on the go. So the possibilities of collaboration, right? When you're sharing with others, they'll also share, you learn.
Okay. So let's talk about the first use case here. And this is related to how we can efficiently handle the customer inquiries. And typically, all the customers expect that we turn around their inquiries in very less time. Okay, but this is a lot of manual and repetitive processes are involved, and that's why this is taking a lot of time. And typically, customer is interacting with the customer service representative, and customer service representative is initiating the request into the CRM software, and that's where the engineering picks up the request and then start working on it. Typically, customer is providing the requirements in terms of the engineering drawings. So what application engineer does is studies this engineering drawings in detail, understand the customer requirements, connect with all the different product databases, and then identify best suited part number that matches to the customer requirement. So this is a lot of manual work and time-consuming work that engineer has to do. But that's not all. Once the product is identified or configured, the newly identified product also needs to be set up into the systems. And here we have we have so many different systems where we need to set up the part. Consider the ERP system. So for one part, we might have to update 100 plus fields just to set up one part into the ERP system. For an example, bills of material, product characteristics, and so on. And we have so many different databases we need to update. So again, this is a lot of manual process that engineer has to do themselves. So what we have done is we have used AI. And that is, we have developed the computer vision-based AI algorithms, which is going to help with the product identification portion here. So what this AI model does is scan these customer drawings, extract the information from the customer drawing, process that information to clearly identify the customer requirements, connect to all the product databases, and generate the quote options, or I would say the solutions for the customer inquiry. That is going to include the bills of material, the cost, the lead time, and everything, right? So what used to take hours together, now with help of AI, we are able to do this in few minutes. And once this product identification is done, we have also developed a Python-based solution, with which we are able to set up this new part into these systems in all the different systems just with the one click. So with this end-to-end process automation, we were not only able to improve our customer handling response time, but then we were also able to reduce the manual and repetitive work for our engineers. So this particular project has immensely helped.
So another insight is from the ISO, how the International Standards Organization is able to pace with these technological changes. And last year they issued, by September last year, I think it was in September, they issued this international standard, the 5259 Part 2, called Artificial Intelligence, Data Quality for Analytics and Machine Learning. So they propose a set of data quality measures, including these ones here. So they propose these 6 dimensions. So, for example, the pharma industry, as I told you, proposed the Alcoa Plus. So those letters represent dimensions. In this case, they suggest these dimensions: the accuracy, which is the correctness of data values. Data should also be completeness. So data should have absence of missing values or records, so they must be complete. The data must be consistent as well, and this regards uniformity across data sets and formats. So standardization, for example, in Lean is very important here. So Lean provides the standardization principle. Timeliness, so that data should be available at the right time, so relevant data in a certain context. The data should be also valid, so validity is another dimension, and traceability, of course, for many industries. For example, the automotive, the airspace industry, food industry, many others. Traceability is a mandatory requirement. Okay, so the ability to track data from origin throughout the value chain and the value stream, it's very important. So some challenges regarding data before trying to relate some Lean tools and Lean principles with AI, and how Lean can help AI and vice versa. So, for example, we can have bias in training data. So we can have biases regarding historical and demographic biases regarding data sets, and it can create problems in the outputs provided by AI algorithms. Another one is lack of standardization. So we have many different ways where data can be stored. Um, the way data is reported. So we have different formats. We have different ways where data is managed, and this can be a challenge as well. And then another one is the scalability. So manual data validation may not scale very well, and then automated tools should be essential, but require careful configuration. So data can be presented in many types, many ways, different. Some data may be validated manually, and eventually the validation it's not properly done. So these are some challenges that we can have in practice.
You know, just complete the statement. The cat is maybe eating 45% as output from LLM, playing, sleeping. I mean, not a big problem. In any case, all these verbs make sense to complete the statement the cat is. But think about this. Now you go to 1 + 1. You need to remember that also in this case, you are not in front of Wolfram model or an arithmetic model. The LLM does know anything about arithmetic, the rules, the operation. It's just predicting with some probability the most probable result. So if you see 3, I mean, you cannot say, oh, what the hell? I mean, it cannot do like that. It's just I asked 1 + 1. You need to remember what's happening behind the covers, okay? It was not designed to do math. Remember about that. Now we have chain of reasoning, a lot of other things to correct. But the core was not meant to do this kind of things. So this is a bit of provocation, but it's a seminal paper. ChatGPT is bullshit in the sense that the models are in an important way indifferent to the truth of their outputs. They do not know anything about the world on which they are answering. Okay? Again, this was to get hype, but remember about this fact. What do we do as Cyberguru? You know, vibe coding is an hype. It's code assisted by AI. It's it's wonderful in the sense that you have 5x, 10x productivity boost. But again, in the spirit of what I said, we need to pay attention to this. It's very, very good to demo, to do prototypes, but to do real production code, we need to pay a lot of attention, okay? The point is that a lot of times the code is good, but it's different from what you expect, and you may introduce a lot of errors that are hard to take in production because they are not designed, the code is not designed by a human. It's statistical code in a sense, okay? This is a huge example. One of the first outage with LLM written code. You see here, I mean, you do not need to be a programmer to understand. There was just a comment, log error, but continue with other installation. So there was a break as a real instruction. The LLMs review the code, took the comment, and what it did is, okay, I read log error, but continue. So let me change this break with continue. It happened, you have the source. This is, I mean, a huge outage that was hard to get after the code was there. No, now you can put in place review, test, whatever. But the spirit is important. You would not expect a human to use the comment to put a continue in the loop. We talk about paradigm shift. So what we need to do? We need to handle these objects as they are. They are probabilistic objects. So if you are fine with introducing some level of uncertainty in your processes, so you can have probability error up to some level, use them. but you need to know about the fact that you are introducing something in your loops, in your process, that is not deterministic, okay? So